A very quick recap on hybridization. So by now I believe we all know about the 3D-dimensional molecular shapes, and if you don't, I certainly recommend you please go back and understand them. These are really important to help understand the main concept of hybridization. The linear shape is 180 degrees away. The triangular planar, we have got the lone pair shapes, and we have got tetrahedral, triangular bipyramid, and octahedral. So coming back to the hybridization. The first bond is always a sigma bond. This means imagine we have got a carbon atom bond into other 4 hydrogen atoms, which is a methane. How many first bond we have? 1, 2, 3, 4. This is the first bond. And in total, how many sigma bonds? We have got 4 bonds. So what's our hybridization now? I believe this is a sp3, but some people may ask me, how do we know? To understand this, please bear in mind this table. We always have S, P, D. But for now, we are not considering the rest, but we have F. That's mainly for postgraduate students. So we're mainly concerned about these for now. S can hold up to 1. P can hold up to 3. D can hold up to 4. But F can hold up to 5. Okay, so if you want to understand, is the hybridization right? We can count it again. S can hold up to 1, yes, but we have got still 3 left. So P, what number do we want to get here? 4 is 3. 1 plus 3 is 4. So the hybridization is sp3. So, but that is not always right, because in some cases we may have double bond. So the second bond is always a pi bond. Alright, yeah. Imagine we have got a carbon bond to other carbon and 2 other hydrogen atoms, and here also 2 other hydrogen atoms. So if we're going to look at this, we can have dot from the middle. So this can show us this is a triangular planar because it's 120 degrees away from each other. But okay, so we already said the first bond is a sigma bond. Just treating this as a sigma bond. So the other bond is a pi bond, we know that. But do we consider the pi bond hybridization? No, we do not consider high pi bonds. So what we're concerned about is what number of sigma bonds we have here. So what is the hybridization of this? Is 1 pi bond and 1 sigma, 2 sigma, 3 sigma. In total, how many sigma? 3 sigma. How many pi? 1 pi. And here, 1 sigma, 2 sigma, again 1 sigma, and again 1 pi. So how many sigma? 3 sigma. How many pi? 1 pi. Going back to the chart, was here, sorry. So if we have 3, it means we need 1 S and 2 P. So it's going to be sp2 and sp2. If you didn't understand that, certainly we can do another example, but I'm sure that is not really hard. Okay, if we can do another example of we can have carbon to oxygen, and that may have another oxygen, which is this is partially positive and this is partially negative. Okay, we can have this pi bond and this pi bond, and we have got 2 pi bonds and 2 sigma bonds, but we always say the sigma bonds first. These are the sigma bonds and these are the pi bonds. So how many pi bonds do we have on the carbon atom? And how many sigma bonds do we have? The sigma bonds we have 2 and the pi bonds we have 2. So what's the hybridization now? How many sigma and how many pi? But we don't consider the pi, so we already know that we have to treat this by a sigma bond. 1, 1. So it's going to be SP. Very straightforward. Alright, so but this is not going to be always as straight as this. So we may also get triple bonds. The third bond is also a pi bond. This means that if you get, let's just give as an example, if you get carbon to another carbon by a triple bond, so it can be whatever, yeah. So we consider the first bond, which is a main bond, is a sigma bond, and the other two are as a pi bonds. So how many bonds? If we consider this again, we can do a dot from the middle, but this is a linear shape, we already know that is 180 degrees, yeah. So the third bond, alright, going back to the chart, how many we have? We have got 1 and 1. This is a sigma bond, so it's going to be again SP. So again, how many sigma and how many pi? We have got 2 and we have got 2. 1, 2 sigma, 1, 2 pi. sp2 hybridization. Very straightforward. So to give you some idea again, this is going to be really helping you to understand this. So sp, whenever you have sp, so you must know that on top of your head, that is going to be a linear shape, 180 degrees. Whenever you have sp2, that is going to be a trigonal planar, which is 120 degrees. Whenever you have sp3, that is going to be a tetrahedral, which is going to be 109.5 degrees away. And whenever you have sp3d, you may have a trigonal bipyramidal. And whenever you have sp3d2, you have octahedral. So giving another example, so you imagine you have got a fluorine. You already know the answer, but just with 6 other chlorine atoms. So what's the hybridization? 1, 2, 3, 4, 5, 6. How many sigma bonds? 6 bonds. So going back to the chart, 1 S, yeah, we have got 3, but it's going to be only 1 plus 3 is going to be 4. Is it enough? No. How many we need? We need 6. So we can borrow some from the D charts. So it's going to be sp3d2, which we already have here. Thank you for watching us.